Alright, so this question is asking you to find the inverse of a matrix if it exists. Now, the first thing that you're going to do when you're finding an inverse is you're going to find the determinant of the matrix. So this is a 2 by 2, so it's going to be downward minus upward, so it'll be 1 times 4 minus 3 times 1, which is just 1. So the determinant of this thing, oops, wrong button. The determinant of this thing is 1. Since it has a non-zero determinant, we can find the inverse. So if we had worked this out and the determinant was 0, you would stop, you'd write no inverse, and you'd move on. But the determinant's 1, so we need to keep going. There's a rule for doing for doing inverses of 2 by 2s by hand. If this is matrix A, this one right here. If that's matrix A, the rule is you take the matrix and you flip the first and fourth elements. So where A was, you put D, where D was, you put A. And then you switch the signs on the second and third elements. You switch the signs. Again, that doesn't mean that the second element, B, will always be negative. Doesn't mean that C will always be negative. It means that you switch the sign. And then you you multiply into the entire matrix 1 over the determinant of A. So 1 divided by the determinant of A is like a scalar now. So let's take our matrix over here, and if it helps, label it. There's A, B, C, and D. First thing we're going to do is we're going to switch the first and fourth elements. So 4 will be there now, 1 will be there. And then we're going to switch the signs on the second and third element. Then we write in our scalar, 1 divided by the determinant, and our determinant was 1, so this is a really nice scalar, because there's nothing really to do. But just to show you, 1 divided by 1 is 1, you take that and you multiply it into each of the terms, and then you rewrite your new matrix. This, 4, -1, -3, 1, is your answer to the question. It asked you to find the inverse of this matrix right here, and that's what we did. We evaluated the determinant, we switched the first and fourth elements, we switched the signs on the second and third, and then we multiplied in our scalar. There's a way to prove whether or not that this inverse actually is the inverse of our original matrix. And the way to do that is you're going to multiply the original matrix. Oops, wrong button. Going to multiply the original matrix, which is 1, 1, 1, 3, 4, times the inverse you created, which is 4, -1, -3, 1. When you multiply that together, you're going to get something called the identity matrix. And the identity matrix will look like this. 1, 0, 0, 1. This is the matrix equivalent right here of getting 1. So this process, taking the original matrix and multiplying it by the inverse you found, is a good check to make sure that you did the process right. As long as you get 1, 0, 0, 1 out, you're good to go. Additionally, if you were given two matrices and you were asked, are these inverses of each other, you could do this process where you multiply them together and see if you get 1, 0, 0, 1, and then the answer to your question would be yes. So, there you go. Inverse of a 2 by 2.